Namaste and welcome back to JEE Mathematics with Typical Monk. This is class 24. Vectors. A number tells you how much, a vector tells you how much and which way. That one extra idea, direction, rebuilds all of geometry into algebra. Two vectors can be multiplied in two utterly different ways. The dot product, which returns a plain number and measures how aligned they are, and the cross product, which returns a whole new vector perpendicular to both, whose length is the area they sweep. Today, dot, cross, triple products, and the geometry they unlock, one idea at a time. Here is what you will master today. First, vector algebra and position vectors. Second, the dot product and projection. Third, the cross product and area. Fourth, the scalar and vector triple products. And fifth, Coplanarity and the geometry applications. One idea at a time. 4 ideas. Run this whole chapter. Look at them together first. A vector, a quantity with both magnitude and direction, written in components along I, j, and k. Two products. The dot product gives a scalar, the cross product gives a vector. The dot. A dot b equals the magnitude of a times the magnitude of b times cosine theta, and it is 0 exactly when the two are perpendicular. Master line. The dot measures alignment, the cross measures the area they span. Now look at the picture. The cross product in 3 dimensions. The cross product. Across B is a vector perpendicular to both A and B. Direction. The right hand rule. Curl your fingers forward towards B and your thumb points along across B. Magnitude. The magnitude of across B equals the magnitude of A times the magnitude of B times sine theta, which is the area of the parallelogram they form. Anti-commutative. B cross A equals minus. Across B and across A is 0. Now the dot product in more depth. Definition. A dot B equals the magnitude of A times the magnitude of B times cosine theta, which also equals A1 B1 plus A2 B2 plus A3 B3. Perpendicular. A dot B is 0 exactly when A and B are perpendicular. Projection. The projection of A onto B is a dot B divided by the magnitude of B. Angle cosine theta equals a dot B divided by the product of their magnitudes, and that gives the angle between them. Now the cross product in more depth. Component form. It is the determinant with I, j, and k across the top row, and the components of A and B in the rows below. Perpendicular. Across B is normal to the plane of A and B. The area of a triangle. It is half the magnitude of the cross product of two of its sides. Parallel test. Across B is 0 exactly when A and B are parallel. The unit normal. Divide across B by its own magnitude to get the unit vector perpendicular to both. Now look at the picture. The dot product seen as a projection. The dot product. A dot B equals the magnitude of A times the magnitude of B times cosine theta, a single number. Projection. Drop a perpendicular from A onto B. The shadow it casts has length, the magnitude of A times cosine theta. Sine. It is positive if the angle is acute, negative if the angle is obtuse, and 0 if they are perpendicular. Use. The dot product finds angles, tests for perpendicularity, and computes work. Now the two triple products. The scalar triple product. A dot B cross C equals the volume of the parallelepiped formed by the 3 vectors. Coplanarity. 3 vectors are coplanar exactly when their scalar triple product is 0. Cyclic. A dot B cross C equals B dot C cross A equals C dot A cross B. A cyclic swap leaves the value unchanged. The vector triple product. Across B cross C equals a dot C times B minus a dot B times C, the back minus cab rule. It lies. The vector triple product lies in the plane of B and C. Now, where vectors meet geometry. The section formula. The position vector of a point dividing a segment in a given ratio. Collinear and coplanar, tested with the cross product and the scalar triple product. area, and volume, found from the cross product and the scalar triple product. Now, match each product to its meaning. A dot B goes to the magnitude of A times the magnitude of B times cosine theta, a scalar. A cross B goes to the magnitude of A times the magnitude of B times sine theta, a vector. A dot B cross C goes to the volume 0 if the vectors are coplanar. And a cross B cross C goes to A dot C times B minus A dot B times C. 4 pairs, each worth memorizing. Now, how many of these statements are correct? Statement 1. The dot product of two vectors is a scalar. Correct. Statement 2. The cross product is commutative. Wrong. It is anti-commutative. B cross A equals minus A cross B. Statement 3. Three vectors are coplanar if their scalar triple product is 0. Correct. So the answer 2 are correct. Statements 1 and 3. The chop is the commuting cross product in statement 2. Now the two mistakes that quietly cost marks. The truth, the dot product is a scalar. The cross product is a vector. The trap, assuming the cross product commutes. In fact, B cross A equals minus A cross B. The second truth, the scalar triple product gives a volume and tests for coplanarity. The second trap, confusing the magnitude of a cross B, which is an area with a sign, with a dot B, which is an alignment with a cosine. Now, test yourself. Answer in your head before the reveal. That is how G speed is built. Here we go. Question 1. The dot product formula. A dot B equals the magnitude of A times the magnitude of B times cosine theta. Question 2. The magnitude of the cross product. The magnitude of A times the magnitude of B times sine theta. Question 3. When are two vectors perpendicular? When a dot B is 0. Question 4. When are three vectors coplanar? When a dot B cross C is 0. And question 5. The vector triple product across B cross C, a dot C times B minus a dot B times C. Let us gather it all in one breath. A vector has magnitude and direction, with components along I, J, and K. The dot product, a dot B, equals the magnitude of A times the magnitude of B times cosine theta, a scalar, 0 when perpendicular. The cross product, the magnitude of A times the magnitude of B times sine theta, a vector perpendicular to both, 0 when parallel. The scalar triple product, the volume, and coplanarity when it is 0. The vector triple product, a dot C times B minus a dot B times C. Next class, three-dimensional geometry, lines and planes in space. Add direction to a number, and geometry becomes arithmetic. The dot product distills two vectors into a single number that measures their alignment. The cross product spins out a new vector, whose length is an area and whose direction is perpendicular to both. Stack them into triple products, and you can compute volumes and test whether points share a plane. Master the two multiplications and three-dimensional geometry. Our next class becomes almost easy. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time, you will crack G. I will see you in the next class.